Apple is famous for phones and brand, but quietly, without owning a single factory, it became maybe the best chip design company on earth. The processors in your iPhone and Mac routinely beat chips from companies that do nothing but make processors. And just recently, Apple did the one thing much of the industry said it couldn't. It built its own cellular modem, one of the hardest chips in existence. So how did a consumer brand turn into a silicon powerhouse? And why was the modem the real test of how good Apple's design team actually is? Let's get into it. First, a key distinction. Apple doesn't manufacture its chips. It's fabless. It designs them and hands the blueprints to a foundry to build. What makes Apple special is that it designs them better than almost anyone. The story starts in 2008 when Apple bought a small, brilliant chip company called PA and began building an in-house silicon team. 2 years later, it shipped its first owned processor in the iPhone 4. Today, Apple designs the main chip in every product it sells: phone, watch, earbuds, laptop, desktop. That didn't happen by luck. It came from a handful of advantages that compound on each other: how Apple builds its cores, how it ties hardware to software, and how it gets the best manufacturing on the planet before anyone else. Let's take them one at a time. Start with the cores, the actual brains of the processor. Apple uses the ARM instruction set, the same basic language as most phone chips. But here's the difference. Apple doesn't buy ARM's off-the-shelf core designs like most of its rivals. It designs its own cores from the ground up, and it designs them unusually wide and deep, able to work on many instructions at once, which is genuinely hard to do well, and it's why Apple's cores have led the industry in single-thread performance for years. Even more important is the metric Apple obsesses over: performance per watt. In a device running on a battery, the chip that does the most work for the least energy wins. It runs faster before it gets hot, and it lasts longer on a charge. Apple's cores have been the benchmark there for over a decade. That core design talent, a deep bench of some of the best processor architects in the world, is the engine everything else is built on. You can't shortcut it, and almost no one else has it. The second advantage is the one competitors can't copy. Apple designs the chip and the software together. Most chip companies sell a processor to someone else, who writes the software for it. Apple does both. The same company designs the silicon, the operating system, and the frameworks that developers build on: the graphics layer, the machine learning layer, the power management. That means Apple can add a block of hardware to the chip, knowing exactly how its software will use it, and tune the whole stack end to end. When it built a dedicated engine for machine learning, it wired it straight into the software that calls it. A company buying a merchant chip simply can't co-design like that. On top of it sits unified memory, shared cleanly between the processor and the graphics, plus huge on-chip caches and cooling design for each specific product. The proof of how powerful this is came in 2020, when Apple moved its entire Mac line off Intel and onto its own chips. And the laptops got faster and ran cooler at the same time. Designing the chip for the software instead of the other way around is the real moat. The third advantage is manufacturing access, where design meets the real world. Apple doesn't build chips, but it is the most important customer of the company that does: TSMC. Apple is first in line on every new generation of TSMC's technology. It was first on the 5-nanometer node, first on 3, and it's first on the 2-nanometer node powering its newest chips in 2026. Being first buys a manufacturing lead of roughly a year to a year and a half over rivals who get the same technology later. Now combine it: the best core designs, built on the newest transistors before anyone else can have them. The gap doesn't add, it multiplies. And the reason Apple gets that privilege is scale. It ships over 1 billion devices, so it can commit to a new node years in advance and fund the enormous research bill that leading-edge chip design now demands. Most companies simply can't afford to play at this level. Apple can and does every single year, which is why the lead has held for more than a decade instead of being a one-time win. Which brings us to the hardest test of all: The modem, the chip that connects your phone to the cellular network. On paper, it sounds mundane. In reality, it may be the single hardest mainstream chip to build. It mixes extremely sensitive radio and analog circuitry with heavy digital processing, and it has to work flawlessly across thousands of carrier networks. Every frequency band and every generation of cellular standard all over the world. The certification is brutal, and the whole field is buried under patents, most of them held by Qualcomm. For years, Apple depended on Qualcomm, fought it in court, and then in 2019 bought Intel's modem business to build its own. It took about 6 years. The first Apple modem, the C1, arrived in the iPhone 16e in 2025. Its successor, the C1X, is roughly twice as fast and more power efficient than the Qualcomm modem it replaces, though it still skips the fastest millimeter wave bands. And notice Apple's angle. It didn't chase the highest peak speed. It chased efficiency by fusing the modem with its own processor and power management to save battery. That's the whole philosophy in a single chip. So here's the verdict. Apple's strength was never a single clever trick. It's a flywheel, an elite in-house design team, control of the entire stack from silicon to software, first access to the best manufacturing on Earth, and the scale to pay for all of it. And each piece makes the others stronger. The modem proves the model. The hardest chip in the industry, the one many said Apple couldn't crack, eventually gave way to the same machine that built everything else, given enough patience and money. But be honest about the limits. Apple still doesn't manufacture anything. It depends entirely on TSMC. It still pays Qualcomm, for now, and its modem still trails on peak speed and millimeter wave. The win isn't raw benchmark leadership. It's efficiency, integration, and independence, plus a roadmap to add the missing pieces and drop Qualcomm entirely within a couple of years. And the real lesson for the rest of the industry is an uncomfortable one. The winning model is deep vertical integration, run by people who control both the chip and the software that runs on it. Plenty of companies are trying to copy it. Almost none of them can, because it isn't one decision, it's 20 years of compounding ones. If you want the real engineering behind the chips inside the devices you actually use, how they're designed, who really makes them, and why it matters, this channel takes it apart one piece at a time. Subscribe if you want the actual semiconductor industry view. No hype, no hot takes, just how the chips really get built. Thanks for watching, and I'll see you in the next one.